to look at different examples of molecules, find out what the nature of the bond is, write the Lewis structure, the Couper structure, and then figure out the shape of the molecule, and then determine the polarity on the molecule. So I'm recording it, so you can always listen to it again once I've uploaded it. I want you to follow and work with me. We've done hydrogen. Okay? So what I'm going to do next is fluorine. So fluorine is F2. What's the nature of the bond between two fluorine atoms? Yes, I don't have to do the calculation, but just to get into the habit, 4 is the electronegativity of fluorine. So 4 minus 4 is 0. So the nature of the bond is pure covalent. And that means that electrons are shared equally. Electrons shared equally. Okay. The Lewis structure would be showing fluorine with its 7 valence electrons, forming a bond with another fluorine atom with its 7 valence electrons. So the 2 electrons that are shared, those are called bonding. That is called a bonding pair. And all the others are called lone pairs. So these electrons are called lone pairs. They are the ones that are in the filled orbitals, valence orbitals. So those are called lone pairs. Okay. The Couper structure just uses a dash, a Couper structure just uses a dash to represent the bond, and this molecule's shape is linear. Just like the hydrogen, the two atoms will lie on a straight line. That's why it's called linear. Okay? Will the molecule be bigger than hydrogen? Yes. Or smaller? Bigger. Yeah. And the molecule as a whole, because the electrons are shared equally, the charge distribution is a 0. So it's a non-polar molecule. Now you can do the same with a molecule like oxygen. The only difference is that oxygen will have a double bond between the atoms, but the nature of the bond is still pure covalent. And what is it 3,5? Yes. So it's 3,5 minus 3,5, which gives us 0. So our conclusion is the same as for fluorine. It's a pure covalent bond because the electrons are shared equally between the atoms. The Lewis structure will look different though, because the Lewis structure will need to show the double bond between the 2 oxygens. Now I'm drawing the crosses, two together along the sides of the oxygen. But that is just a model on paper. And then there will be a sharing of these electrons taking place between the 2 oxygens. Sorry, I just used crosses. I'm so used to using crosses that in this one I also just use crosses.
Wait, aren't you supposed to?
No, you can. You can use crosses or dots. It doesn't matter.
No, it's fine.
It's just,
She wants to show us the difference.
yeah. So here we have two bonding pairs, and we have 1, 2, 3, 4, 5, too many. 1, 2, 3, 4 lone pairs. So up there we had 6 lone pairs and 1 bonding pair. Here we have 2 bonding pairs
And 4 lone pairs.
and 4 lone pairs.
Also linear, no?
And yes, because we only have 2 atoms in the molecule, it's a linear molecule. And the molecule as a whole is non-polar because the charge distribution
It's equal.
is, we call it symmetrical. So the electrons are shared equally between the 2 atoms, and they spread the charge equally on the 2 atoms, although there is no charge.
When will it be polar?
Wait, Tina. Wait. Next, just to get the triple bond story in, is nitrogen. So these have single bonds. Because there is only 1 bonding pair, this will have double bonds. Because you have 2 bonding pairs, and here we'll have triple bonds. Because we'll have 3 bonding pairs. What's the difference in electronegativity?
3 minus 3.
3 minus 3 is 0. So the same conclusion that we had there applies here. That it's a pure covalent bond. The electrons are shared equally between the atoms. The Lewis structure will be nitrogen to nitrogen with 3 bonding pairs between the atoms. So how many lone pairs on this nitrogen?
1.
1 lone pair. How many lone pairs on this nitrogen? 1 lone pair. Okay. So we have 3 bonding pairs and 1 lone pair. And the Couper structure would look
3 dashes.
3 dashes to nitrogen. The molecule is linear and the polarity is non-polar.
Huh?
Yes.
Why is there only 1 lone pair?
Because nitrogen's got only 5 valence electrons. 1, 2, 3, 4, 5. And you can't have more. Another thing I want to show, so you see this nitrogen, the fluorine has 7 valence electrons.
But man, isn't that
Oxygen's got 6 valence electrons. Nitrogen's got 5 valence electrons.
Oh, yeah, they are two.
Oh, sorry. Yes, you're right.
One lone.
Thank you, Marcus. Sorry
So,
for...
ma'am, you look at the...
Yes, the whole
the
molecule. Sorry.
Okay.
Thank you for fixing me up here. So it's 2 lone pairs and 3 bonding pairs. You're right. Is the octet rule obeyed?
No, yes, actually, yes.
Yes.
Yes. Yes.
How many electrons are there around this fluorine atom?
8.
8. How many electrons are around this fluorine atom? 8. How many electrons are there around this oxygen atom?
8.
And around this oxygen atom?
8.
And around this nitrogen atom?
8.
And around that nitrogen atom.
8.
So the octet rule is obeyed. That is why nitrogen is a stable molecule. Oxygen is a stable molecule. Fluorine is also stable in its molecular form, but it's highly toxic. Okay. Let's move to Tina's idea of a polar molecule.
It's going to get posted on the group.
Now, we're following the same pattern. Let's look at something that we've got in our stomachs, hydrochloric acid. Now, I've got 2 different atoms in the bond. What is the nature of the bond between hydrogen and chlorine?
It's a degree of polarity. It's actually polar polarity.
So, what is it?
3 minus 2.
3 minus 2, 1, that is 0,9. So the nature of the bond is polar covalent. It means that the electron shared is not shared equally. I can say the bonding electrons. Okay, what was next? Lewis structure.
Yes.
So hydrogen's got 1 electron to share and chlorine's got 1 electron to share, but chlorine's like fluorine, it's got 7 valence electrons. Okay? So you've got 1 bonding pair and you've got 3 lone pairs. The Couper structure is H-Cl. Now here I can indicate with a kind of an arrow that the electron spends more time on the chlorine. So chlorine, because chlorine has the higher electronegativity. Hydrogen's electronegativity is less. So chlorine is polarized negatively and hydrogen is polarized positively. There is an asymmetric charge distribution. because these electrons are not shared equally. You have an asymmetric charge distribution, and your molecule will be a polar molecule. Yes, it is linear. It lies on a straight line still. It is linear. Okay. Pardon? Alright, so it's a polar molecule, the first polar molecule that we have discussed. We'll continue this next time I see you.
Next week, man, not next